That way everyone knows to refresh. It's not even refreshing on my side. Let's see. Oh, it's slow this morning. Wow, there it goes. All right, good morning, everyone. How you doing today? Even floofier than last night, huh? Almost got that 80s thing going on with the like poof ball up front. Remember when guys did the big like kind of emo mopey curly poof in the 80s? We're almost there. Not what I'm going for. How y'all doing this morning? Hope everyone's well. Had a good 4th of July. Put my little charging cord back here, so. All right, so this morning we're gonna do a little talking some rocks. Make sure the chat's on live chat. And sound is good, right? Yep, okay. So let's flip this around, show you the books I got here today. Oh, nice, Jackie. Perfect. So, got my little books we looked at last time here. And I figured we could talk some basic geology. Maybe we'll use the next few lives to just go through the very basics of, geology, and maybe help some people learn how to identify stuff. Learn new things together. Even if I feel like I know some of the basics, every time I read these things, I still end up relearning something I forgot or learning something new. I'm like, oh yeah, sweet. Or like put new things together that I didn't process before. So it's really good to keep going back through that all. But good morning, Bear. Good morning, Jackie. We got Unheard Voice and Jeff. Let me open the window. We'll get a little more light in here. And of course, get a little coffee, because I need a wee bit more coffee. Although my ice melted in my iced coffee. Alrighty. So let's adjust this a wee bit. I wasn't saying good morning to Chris's voice. Well, yeah, and I'm not an unheard voice. See, I am the heard voice. The rest of you are unheard. But there's only one unheard voice. Just to keep it confusing for those watching in the future, I'm talking about someone in the chat. If you're not watching the live chat. Anyway, so as I mentioned, I wanted to get into some of the basics of igneous rocks, metamorphic rocks, sedimentary, and last time we talked about metamorphic a little bit, but we're just going to kind of restart, go over igneous a bunch today. Next time we'll go deeper into metamorphic, and then touch on the sedimentary. Some people say sedimentary, whatever. English and British pronunciation, pronounce, whatever. Words are hard, yo. Anyway, but first and foremost and most important, we gotta start with the most basics, which of course is how we even get all the different rocks and minerals on Earth, and how this process even happens, which is the fact that Earth is alive. And unlike a lot of planets and moons in our solar system, we are geologically active and have been for a long time, and currently are. The planet is very alive and moving, as you all know. We get volcanoes, we get plate tectonics, and that is all caused by a few forms, but you have radiogenic heat, which is the leftover heat from the core. It is slowly cooling. We're losing heat, but the radiogenic heat that radiates out heats the mantle, and you get these little plumes, and you get the convection currents. And those convection currents, like, think of the semi-liquid rock I mentioned before. It's like a plastic. It's not actually a liquid, even though we talk about it being like a liquid. It's more like a plastic flowing goo. But that convection leads to what we get in the oceanic area. So in the oceanic crust, we get the rifts. And where it's thinnest, out in the middle, that rising magma, it convects and goes all around, and that's what kind of helps push and pull it apart, and it helps rise up the middle. And that magma cools, goes back down, and it just keeps circling around like that. And all the places where it's, I'm sorry, we got a helicopter. But all the places where it's thinnest and comes up in the oceanic thin spots, we can go and, we've sent a lot of explorers down there and looked at these little spots. And what's really interesting is all those ridges you see that are parallel lines. What's really, really fun in those is when we go and look at those layers, we can detect one of the ways that we actually have found proof of the magnetic field flipping through history is looking at the way that the iron crystals and stuff align in this. So when iron forms in the lithosphere there, it's aligned with the magnetic pull when the magma cools. And then every one of these little ridges or so, over time, our magnetic field had shifted on Earth. The North Pole becomes the South Pole, and vice versa. And it's done this many, many times. We're actually wondering if it's about to happen again right now. But every time that happens, you can see it recorded in these layers because, yeah, it's flipped. So when we do core drilling and different stuff, it's fun to look at those samples. Anywho, so that's all basaltic because it's fresh magma coming up. It's a very heavy just basalt flow that we get in the oceanic crusts. But then as it approaches the continents, so here we are on the continents, right? And the continents are not all just basalt. As you'll know, it's a lot of more silicate-rich materials. And there's a couple reasons for that. So one, what happens is as the oceanic ridges or oceanic crusts push way over and eventually reach the continental crust, they subduct, which is that they're heavier, and so they go under the continental crust. Because the continental crust is made of more silicates and the oceanic crust is just purely mafic basalt, it's a lot heavier, so it goes underneath. While it goes underneath, that causes a lot of friction and extra heating here, and it actually gets hotter here than it normally would be from that subduction and the friction. That causes extra melting here, and so you have the mafic material getting heated, rising up through the silicate-rich material, and that's how we get fun materials like rhyolites, and that's how you get Mount St. Helens. And it's a very viscous, thick, not just silica, not just mafic, it's a nice mixed rock. And you get that different type of formation instead of just, rich silicates. So that's a little bit, really, really quick touch on some of the basics of where the more mafic materials come from, so that when I talk about the igneous rocks, it'll make a little bit more sense. But the igneous is the stuff that comes straight from magma, straight from volcanoes, straight out of the oceanic rifts, but not all volcanoes. So that's why, we got to specify, and I wanted to show that first, because some volcanoes, again, like I said, Mount St. Helens, come up through a subduction zone, and that causes them to have much more silicate-rich materials. You get more pyroclastic flows, explosive formations. Yeah, fun stuff. So some of the basics, though, on igneous rocks, I wasn't sure how much we were going to touch on all of it, and if I was just going to actually read you stuff out of the book. Obviously, I'm just telling you a lot of it from memory, from school, plus what I've read in these books, and using their pictures as a guide here. But igneous rocks, actually, I really like this one a lot more. This diagram was much better. I feel like this one was pretty informative. Okay. So we classify igneous rocks by their, mostly their composition. Where is it? Hold on. Oh, I thought this one had it. Where is it? Hold on. Is it in the mineral content one? Lava. Huh. Hold on. Oh, just kidding. Maybe it is this other book. One of them has... Oh, it is this. Okay. Less than 10% quartz and between 45 and 55% total silica. Plagioclase feldspar is usually sodium-rich. Augite is also an essential component of spilite. The pyroxene content is often... Okay, so this is specifically spilite. So it's when we're going through the book. Huh. Maybe this one has it. One of them has a more specific break. It has a specific breakdown of what chemical components are in igneous rock. Oh, this one. Okay. Maybe I was looking for this one. That's not it either. Man, it's in one of my 3 books. Anyway. Nope. We'll find it. Hold on. Oh, maybe it was this. Oh, okay. Yep. I just read a little bit more. Good morning. Hi. Good morning, Gems. I'm just meandering through books and was talking a little bit about igneous rocks and kind of lost my train of thought here. I don't remember what I was saying a minute ago. I was looking for something here. Talking about the composition of what's mostly in them. Here we go. Yeah, the commonest. I like that, the commonest. The most common minerals to form are quartz, feldspars, micas, amphiboles, and pyroxenes and olivine. This is what I was looking for. I knew it was somewhere in one of these books. But, so within your igneous rocks, this is what you most commonly find. And that's why I went looking for the olivine crystals in the basaltic flow in Idaho. I had read somewhere you could find big olivine crystals. But all we found was a whole bunch of mica and feldspar crystals. So, we're not going to go through the whole entire thing here, but there is one about the crystal formation. Yeah, this one, okay. So I was talking about the metamorphic rocks, which we'll get back into tomorrow, but this one is a lot different because they form at much hotter temperatures. They start out much higher temps than metamorphic stuff is exposed to. So each mineral crystallizes at a different temperature. Olivine and pyroxene set at over 1,000 degrees Celsius, which is 1,832 degrees Fahrenheit. Silicate minerals such as quartz don't freeze until temperatures are as low as 650 degrees Celsius or 1,200 degrees Fahrenheit. So magmas crystallize progressively, with some minerals forming earlier than others. So that's why, basically, when we get a nice sample like... Oh, maybe I should have pulled some of my samples out. Or maybe it was in this other one. Different crystals, as it says, form at different rates. And when you look at a big sample of a rock, you'll have huge crystals of one thing, but then tiny little crystals of another thing, but they might have formed in the same rock at the same time. It's not always an inclusion that formed secondary at a later time. It might be, but it might not be. And that's where dating comes in, and that's much more advanced than the kind of stuff we've gotten into in school. We've learned how to do like radiometric dating, radiocarbon dating, all the, well, not just radiocarbon, all the different dating with different radioactive elements, and learning about the half-lives and the decay of radioactive elements and how you use that to date each individual thing and can isolate it out of each mineral, and like that gets so advanced. Let's see. Nope, don't want that one. How you doing this morning, Gems, as I meander through my book? The one I want to show about the basalt flows. Where's the basalt flow one? I should have used bookmarks, or even gone through my book before this. Oh, hey, here we go. That was a good one about the crystals. So, something I forgot to mention. So when the flows of lava happen, and you get these huge columns that cool, it's like you go to Hawaii and you see the lava that's flowing out, it can take a very, very long time to cool. And depending on how long it cools, and if it's cooling up on the surface or under hundreds of feet of lava. So when you get really thick basalt flows, and they're like hundreds of feet thick, big, huge, thick flow, the stuff on the bottom can take a very, very long time to cool. When it does, that allows time for the crystals to grow. The stuff at the very surface, the top of the flow, is going to create a quick crust, cool very fast, be all porous and spongy, and you're not going to find crystals in it. I made the mistake when I first went out and looked through all the basalt flows. I'm like, cool, basalt just has crystals in it. And so we just went to the very top of the basalt flows and started digging through them. We had no idea you were supposed to go down the canyon, down to the bottom, and look through the bottom parts of the basalt flows where it takes longer to cool and more crystals can form. So if you're out and you're looking and you find big basalt columns and stuff, you want to, look where it's more probable to get crystal formation. And that's going to be lower down in where it takes longer to cool. One little thing to look for. It is broken down by grain size. So you can see the larger stuff is what they call gabbro. When I talk about a lot of igneous stuff, I tend to call a lot of things basalt, which I guess is inaccurate, is by grain size, and the larger stuff is going to be the gabbro. The medium grain stuff is going to be basalt. And then the very, very fine grain, tiny stuff. Oh, actually, other way around. Oh, no, that's right. The tiny, fine grain stuff is the basalt. The medium grain stuff is dolerite. It actually says right here. If I had just read it instead. So yeah, the medium grain is dolerite. The very, very fine grain stuff is going to be the basalt. And you can't see the grains of basalt without a microscope. With a lens, you can see the grains of dolerite. So if you've got a little pocket lens, and you're taking your little, what do you call them? People call them different things, but your little spyglass tool, your little magnifier, your hand lens. If you can take a little hand lens out in the field, and under a normal hand lens, you can see the grain size, and it still looks small, but you can see the individual grain sizes, then you're dealing with a dolerite. If you don't need a lens and you can easily see the grain sizes and see larger crystals, then you're dealing with gabbro. Otherwise, then it's actual basalt. So a lot of the stuff I brought home, I had been calling basalt, is actually definitely a dolerite. So this is why it gets a little more interesting the more you get into it, and people will correct you online, and you'll post something like, well, technically it's not that, it's this, because even though there's these three classifications, then each one of these can be broken down into many other rocks based on their actual crystal and matrix composition. So, such as here, you're going to look at the colors, and this is going to help you determine, people say, oh, well, that's probably a rhyolite just based on looking at the color. Not always true. It might also depend on what it actually is composed of. This, for example, this says rhyolite, very light colored. I've seen tons of people point out on my thunder eggs the more medium colored stuff. They're like, oh, that's definitely rhyolite. And it's like, oh, they have no, I don't know. You have no proof until you actually run a bunch of tests on it. But in general, this does say rhyolite has over 65% silica, over 10% quartz. Gives it a lighter color because it's heavier and silica rich. And then andesite has 55 to 65% silica, I guess is lacking the quartz. So that's why it doesn't have as light of a color, And then basalt, 45 to 55% silica. And of course, silica is just going to be, what almost all of your basic quartzes and a lot of your basic crystals that we all deal with are made of. SiO2 is silicate. Si is silica. O2 is the oxidized, or it shows that it's an oxidized crystalline structure, O2. Let's see, there's something about that in here. Nope, maybe that's in the other book. We're going to keep flipping back and forth. Well, anyway, I did want to talk about which minerals we usually find in the igneous rocks versus the metamorphic rocks like we were talking about last time. So as I mentioned already, quartz, because it does have a high silica content, you get all sorts of different quartzes and olivine crystals form in it naturally. We have the only real crystal I have that forms in basalt I can show you right here is this one. Hold on. And it's probably one of my favorites. This one's courtesy of LXR. It's actually got a bunch of basalt in it, but some peridot here. There's little chunks of the basalt still in the peridot. Some of it is a little iron rich sometimes, depending on where you get it. Sometimes there's not enough iron in it to set off a metal detector. Sometimes there is. Sometimes it's a little magnetic. Sometimes it's not. Again, that's why it's just the basics. Basalt is not like a overall defining characteristic. When you talk about each mineral and what exactly is in it and break it down, that's when you get into much more specific rocks. So, we're just trying to talk about very basic stuff here. A little bit of peridot. So that would be as the magma slowly cooled, little pockets of the olivine that were intermixed throughout the rock. So you got to think you have a little slurry of hot, liquidy, or semi-plastic-like rock and stuff flowing around, and all the minerals, chemicals, and stuff that would make up that, the olivines and feldspars, all that different stuff mixed together. But as it starts to cool, it's able to slowly solidify into different layers and densities. And because the olivine has a similar, or the same density, little pockets of it can cool at the same rate and come together and end up forming little crystalline structures together. So throughout the big conglomerate of basalt, you get little tiny pockets that form little olivine crystals. And as you go through this vesicular basalt, it looks all bubbly and whatnot, that just can be filled with different crystals that cool at different rates. And that's why it can actually be, in some areas, you go see them mining certain gemstones where they're pulling out tons and tons of one crystal, but every once in a while they find a little pocket of another type of crystal. But it's just like a very small deposit, and it's a much more rare crystal because there was a smaller concentration of that within the original mix. And as it solidified, that small little bit happened to form a crystal. And when you think about that, and think about how these things formed, then you also have to think about how the host rock around it probably has a lot of the same chemical makeup as those crystals, and the same stuff that would be able to form those crystals. Would be really cool, and I guess we already are synthesizing it in ways, is to be able to take those host rocks and refine them down and grow crystals in the lab out of those minerals that are still locked up within the host and never got a chance to condense and solidify into their own crystalline structure. That'd be interesting. So yeah, that's some of the ramblings of me being mildly caffeinated and not yet fed this morning. Does anyone happen to have any questions? I almost said class, but this wasn't that educational. That was me just skimming my book. Given a little bit of knowledge I have, did not go even read through everything. But if anyone has any questions, we can try and look it up or get more detailed. I was just reading this. Yeah, the rate at which it cools helps determine its composition and the resultant characteristics. It includes grain size, crystal shape, mineral content, and overall color. Yeah. So the rate at which magma cools determines the overall grain size, crystal structure, crystal habit, and whether or not large crystals can form. That's your basics of igneous rock. And we went a little bit over the plate tectonics. I need just a list of which crystals form only in igneous rocks. Let's see. Silicates. Thought one of the pages had a list broken down by... I'll flip this around. Oh, camera's a little tilted there, huh? Boop. I bored people to death, I think. How many people fell back asleep? What's the difference between peridot and olivine? Is it just a color thing? Ooh, that's a really good question. So let's look up peridot versus olivine. See if we can do this without Google, yeah? It's the fun of the book sometimes. You have a question and see... Because I feel like we covered this in school and I can't remember. I feel like olivine and pyroxene and that stuff was on the same family, but now I don't remember. That was 2 years ago. All right, so silicates. Probably need the light on just in case. Oh, no, that just makes a bright spot, doesn't it? All right, so again, as I mentioned before, I was probably wrong because it's probably not an oxidized thing, but silicates are SiO, like quartz is SiO2, is the basic quartz. Si is a silicate O, single linked O, tetrahedra. Oh, so just an oxygen? Wait, so just an oxygen molecule. Or oxygen's O2. Yeah, see, I don't remember. I did that stuff so long ago. Yeah, that's a lot of... By sharing 3 oxygen ions. Framework. Okay, so yeah, it's just silica and oxygen in different formations for your basic silicates. Okay, and then other things, other chemicals. Oop. Sorry, I was trying to move around my tripod and kicked it. So what is an olivine? It's an Mg, so magnesium, Mg2, magnesium SiO4. So it's not the same as SiO2 as quartz. It's got an extra two extra oxygen. So magnesium, silicate and oxygen, Fe, so iron, magnesium, silicate, iron, SiO4. Oh, okay, so these are two, I see. It's a magnesium silicate and an iron silicate attached. It's an alternating magnesium, iron, attached silicates. And so they have the extra, that's why there's the extra oxygen, is so that they can bond. So Fe2 bonded with an SiO4, and an Mg2 bonded with an SiO4. Okay. So that's olivine. Let's see if there's a difference or not in peridot. Or does, actually, let's read this. Does it just say it is peridot? This group of minerals forms thick tubular crystals frequently with wedge-shaped terminations. Other habits are massive, compact, and granular. The color is green, greenish-yellow, yellowish-brown, brown, and white, and the streak is colorless. They are transparent to translucent minerals, and they have a viscous luster. The gem variety of forstoritic olivine is called peridot. Boom. So the gem variety of forstoritic olivine is called peridot. There you go. Peridot is an olivine crystal. Formation. It's an end member of the olivine group of minerals. Forsterite forms in basic and ultra basic igneous rocks and is also found in marbles. Not in little glass marbles, no, in different types of marble, which is interesting. I actually have a chunk of marble with olivine in it. I wouldn't call it peridot, but it's definitely olivine within a marble. It is rich in magnesium, phyllite, and other end members, and is rich in iron and forms in acid igneous rocks which have cooled rapidly. So these are not slow cooling rocks, these are more rapid cooling igneous rocks. Okay. Olivine is soluble in hydrochloric acid with gelatinization. Oh, that's interesting. So it turns to a jello. Olivine breaks down to a gel-like substance in hydrochloric acid. That's fun. Don't clean your olivine and peridots with hydrochloric acid. Got that? You'll turn them into jelly. Epido? Yeah, I think epido. Let's see if we can look that up. I think epido just is on the more yellow variety, right? The greenish yellow. Let's see if there's something about epido in here. Maybe not. It's got a separate page. Epido. So, no, it is very different. Okay, nope. Ooh, okay. So, let's see. CAFEALSIOOH. Ooh, I don't know what half of those are. So it's got aluminum, so calcium, iron, aluminum, silicon, oxygen, OH. Okay, I just don't know what the OH is. What's OH? Is that an oxygen hydrogen? That might just be an oxygen and hydrogen single bond. Okay, so calcium 2, iron with a +3 charge, and an aluminum and a silicate oxygen 4. There's 3 of those, 2 of those to 1 of those to an oxygen hydrogen bond. Okay. Interesting. I think I got that right. I might be very wrong. You can look that up if you want. I'm trying to get learn the like composition stuff. Oh, that's what I need is another chemistry class. That's next up when I return to school. Anyway, so let me get a sip of coffee before I read that one. And see, this is a moment where I'm happy to be wrong. I totally just said epido, I thought, was the yellowish variety of peridot. I think I'd heard that somewhere along the line, and I'm happy to learn right here what it actually is, and hopefully put this away in my memory to remember next time epido and peridot, not the same. Hold on. Make olivine jello now. I just realized I'm not seeing all the chat. Why is your comment blocked? Oh, weird. Okay. I blocked his comment that said epido looks black. This picture is not the best picture to show its color. Seems like it's got a green color there. Slight greenish to it. I wish I could like turn the crystal so we could see light through it, but... So, its hardness is 6 to 7. Specific gravity 3.35 to 3.5. I didn't show this on the peridot as a counter, or the olivine. So, specific gravity is 3.35 to 35, so very small range on this. But it's a very large range on this because they're talking about all olivine crystals, which come in a huge different variation and group. But they are 6.5 to 7. They're very similar on the hardness. This has a larger range of hardness of 6 to 7, so that's kind of interesting. Must just depend on how solid it forms and if it has any other inclusive minerals in it. Hey, Captain. How you doing, Chaos? And your volume doesn't work on YouTube videos? What? Hey there, Jeremiah. So let's see. I was going to read the epido here for those who don't want to read it, but want to hear it. So epido, occurring as a prismatic sorry, I was trying to read through my phone screen and the chat's popping up and covered it and I couldn't read anything. I should not read it through my phone screen. Okay. Occurring as prismatic crystals, which are often striated, epido also forms thick, tubular, and acicular crystals. Acicular crystals. So that's almost circular, but not? I don't know. So that's a word I need to look up. Acicular crystals. Other habits are massive, granular, and fibrous. The color is yellowish green to green brownish green. To green brownish green to greenish black or black. There is a colorless or grayish streak. An epido is a transparent to nearly opaque mineral, and it has a viscous luster. It forms in metamorphic and igneous rocks. See, I didn't know that. Forms in metamorphic and igneous rocks. As long as it has the right composition and is able to get deep and hot enough, I guess it's able to form. It doesn't require enough like heat or certain minerals to be only in igneous rocks, I guess. Just needs the right composition. It is insoluble and fuses fairly easily. Okay, so unlike the peridot, which is going to turn to jelly in the hydrochloric acid, this is not soluble in any acids. Very cool. Let me see chat. Any other questions? That's interesting. You mean you recorded a video and there's no sound of your voice? Like when you uploaded? Huh. I don't use YouTube editor or anything for uploading, Al. I use the video editor and everything on my phone for videos and upload that to YouTube. For lives, I've never had any issues. Yeah, I'm not sure if... Are you using the YouTube editor to upload? Let's see. So garnets, which we talked about last time, form in metamorphic. That's what brought it up. We'd been talking about garnets, and I was like, let's talk about metamorphic rocks. Yeah, I just used my phone's built-in video, just my iPhone's built-in camera app to record my videos, and then I put it all into the Video Leap editor. There's a free version, but I use the paid version, and I edit everything in there. It's very simple, and then you export that to your phone, and then upload that done and edited video straight to YouTube, but done, boom, nothing else to do. You did a short and there was no... Oh, for shorts. Okay, there's an issue sometimes with shorts, especially if you chose a song. So if you're uploading a short, make sure before you go through all the pages, there's somewhere to click like the sounds. It'll be at the top of your screen because you're looking at it vertical for shorts. And usually at the top of your screen, there's a thing like add music or sounds or whatever. If you're on the first page, if you're on the page after that, it's like down at the bottom, there's some sound settings. You have to click that and make sure original sound is turned all the way up. That's the sound for your video. Make sure the original sound is turned up. Because if you have original sound turned down, that means your voice and everything is turned off. So hopefully that works. Hopefully that helps for you. Hopefully it's just something where maybe it was auto turned down through the short settings or something. Yeah. Zoisite. Yes. There we go. I knew it was close. So zoisite. Oh, okay. Very similar here. So, is that calcium something? Or is Ca2 a calcium? I feel like that's calcium. I hope I'm not wrong. Could be wrong. That's something we should look up. Do not take my word for these. I am guessing on these as I read them, but I'm pretty sure it's calcium, aluminum, SiO4, which is a silicate, SiO2 is quartz. So it's just got extra oxygen, and then oxygen, hydrogen, I believe, as we said last time. So I think it's calcium, aluminum, silicate, oxygen, hydrogen bond, which I don't know if there's a name for an oxygen, hydrogen bond like that. Maybe that's an oxide of some sort. I have no idea. Ah, cool. Thank you for the confirmation, Bear. So zoisite has a hardness of 6.5 to 7. Looking at a specific gravity of exactly 3.55. That is very nice for testing. You like to see whole hard numbers and not a range of numbers. That sure makes testing easier. And so we'll read this one real quick and go on to crocite. I think it's crocite. I don't know, that's how I've always said it. So zoisite. This mineral occurs as prismatic crystals, which often have deep vertical striations. It also forms in massive, compact, and columnar habits. The color may be white, gray, green, greenish-brown, pink, or thulite, colorless, blue, or purple, as in tanzanite. There is a colorless streak. It is transparent to translucent mineral, and the luster is viscous. I said lustrous as vister. Formation. Zoisite forms in many rocks, including metamorphosed sediments and granites. It is soluble in acids. I think that includes pretty much all acids will break down a zoisite. So don't put your zoisites in acids to clean them, people. Unless you want to give them an acid bath for texture treatment. There's some thulite. Let's see. I think crocite. Willemite. Hey, we got a bunch of that. So this is what we got at the New Jersey deposit. This is from the New Jersey mine. This is the stuff that glows green. The Willemite is the really... So I wasn't aware. It's hexagonal prismatic crystals, which are frequently terminated by rhombohedra, are formed by this mineral. It may occur in massive, fibrous, compact, and granular habits. Willemite may be white, colorless, gray, green, yellow, brown, or reddish. The streak is colorless. It is transparent to translucent and has viscous or resinous luster. Forms in an oxide zone of zinc ore deposits in veins by secondary alteration and is metamorphosed limestone rocks. Okay. That changes a lot. I thought it was more calcite related, but it is a zinc silicate. Okay. It looks like calcite. I will have to not say that it looks like calcite, or not say that I think it's calcite anymore, because now we know it's not. Let's see. There's talk of tektites in these books about what they are. It doesn't go into the specifics of different tektites, I don't think. We can look in a minute. Where is crocite? Ooh, look at how pretty that is. Look at that hemimorphite. Botryoidal, hemimorphite. Yummy, yummy, yummy. I want that in my tummy. Just kidding. Don't eat rocks. Don't lick rocks. Let's see. Crocite. Wait. Oh. They've got chromite. There's no crocite in that book. Let's check the other one. Good morning, Jenny. How are you? And anyone else I may have missed join, I'm sorry. Good morning. Yes, actually. No, that's right. So people, instead of calcite, it is zincite. That's what... I mean, they literally told us that the mineral is a willemite and zincite. So I had been saying that it was zincite. She told us the zincite was red and willemite was green. So yeah, I guess the ones that glow just red are zincite, and if it has the right composition to glow green, it's the willemite. But they are the same family of that mineral. Okay, oh, this is the glossary. Oh, what was that word I wanted before? Wonder if it would be in this glossary. Now I don't remember what word it was. We have to go back and look. All right, crocite. Also not in here. Wow. Well, I'm sorry. There's no crocite in these books, my friend. Do you know another name for it? Or crocite? I don't remember. What was it? Let's see. Yeah, crocite. Crocoit. Yeah, Chaos. Do you know a different name for it? Neon apatite is that shade of blue. Oh, you know what also? That might... Hold on. That reminds me. I need to figure out what these are. No, tektite's not the word. No, I know tektite. There was a word I was reading on one of the pages earlier that was a very technical word, and I wasn't sure what it meant. I was like, I'm gonna have to look that one up. So this I found in a tailings pile at an old mine in Utah, and this is not the kind of stuff they were after. They threw away. If I could show you under a macro right now, each one of those little balls, each tiny little sphere of crystals there is covered in weird little straight fan blades of crystals. They're not little tiny pointed druzy crystals, they're little fan blades. And I'm not sure what this mineral is, but I've been trying to figure it out for a while. Oh look, you can almost see it right there, look. See how they're like, almost like calcite fan blades? I have no idea what I found. And it has blue and a greenish variety on the same rock. Yeah, so this is an old tailings pile up in Utah from an old mine that closed down. This is one I had to evacuate at just as I got to the tailings pile. Hiked way up the mountain. It's very steep, up a steep hill. Up at the ski resorts in Utah, up at like where Snowbird is. So I was up in like the Snowbird area, and I got up there, and as soon as I get to the top, story time. So as soon as I get up there to the tailings pile, I'm like, wow, this is so much bigger than it looked on Google Maps. It's huge, and there's that stuff is laying everywhere. I'm just like, oh, there's so much, and I start trying to scramble up the side of the tailings pile, which is a no-no. This is a true tailings pile where they just went and dumped stuff off the side of a mountain, so it's as steep as stuff can be and slide down. It's not graded or anything. It was just a steep slide, so every time I try to go up, all the sediment and stuff just keeps coming down, and I kept going up and sliding down and causing small little landslides of sediment. But I'm trying to scramble up, I'm like, I've got to find some cool stuff. And the problem is, up there, Gems, is the host rock. So the layers up in these mountains, it's not horizontal layers. They're very small layers. There's lots of layers, and the mountains have been turned. Instead of like this, all the layers and striations are like this through the whole mountainside up there in Utah. So like every few feet, sometimes every few inches to few feet, you're in a new layer sideways instead of going vertical. So they just go into the mountains sideways and take out all these different minerals, and there's tons of different things. There's marble up in those mountains, lots of granite, marbles, limestone, dolostone, all sorts of different. There's gold, there's silver, there's iron, there's platinum, there's uranium. Yeah, they pull out tons of copper, all sorts of things in those mines. So the reports there on like MinDat and stuff are, it's insane. When you look at those reports, it's like, there's so many minerals and so many things. And I went through a bunch of them and couldn't quite find one that matched that. Anyway, so I'm scrambling up. And I got like 20 feet up this little tailings pile and kept like spidering my way up and grabbing up. Whew, sorry, it's sweaty and hot in here. It's like 80 degrees already this morning. And I don't have my AC on because it's too loud for the stream. So it was like pretty clear day when I set out and went up there, and that's why I chose that day to go up. But I got up there, I'm like spidering out, crawling up the tailings pile, finally got a good spot, and I sit back. I'm like, okay, I just spent 20-30 minutes trying to get it like maybe 20 feet up the tailings pile because I kept getting up, falling down, getting up, falling down. And I got this little spot that seemed stable, had a couple big boulders and rocks in it, and I like set myself up on. I like wouldn't let go of my backpack, because if I go sliding down and my backpack is stuck up there, that's gonna suck. So I'm also like trying to keep my backpack on me, but then I like take it off, put it on my front, wrap it around me, put it on my front, and sit back on the tailings pile and like sprawl out so that I won't slide down and like try and grab stuff. And that's when I noticed all of a sudden the blue sky is disappearing. And the really nice day I had was not turning cloudy, but crazy smoky. And it was blue sky to my left, and it was a smoky black sky to my right, and coming fast. Almost like I was like, oh no, there's a forest fire here in the canyon, and it's coming so fast it's blocking out the sky. And not only that, I've got to get down an hour-ish hike down the mountain to get back to my car, and this smoke is coming up. So I was terrified. I called Whitney, I called my partner, I called my mom, I told people what was going on. This was 2 years ago in Utah, 2 or 3 years ago in Utah. But I called people, I'm like, hey, there's like a fire or something, will you look up what's going on? Like I amazingly had service up in that spot of the mountain because of the ski resorts, and they have the towers and stuff up there. I luckily had service up there, but it's like, will you guys see if the fire's near me? What's going on? I don't have great service, but like I'm going to just scramble down the mountain and not take time to look it up. And I scrambled and rushed down the mountain, got to my car. By the time I got to my car, couldn't see a quarter of a mile. It was so thick black, like just thick smoke coming through. I was choking on it by running down the mountain, and I was terrified. I was pretty sure a fire was coming up that canyon, but nope. Turned out like it was actually a ways away, and it just was so bad. The wind, it's a very narrow canyon, and the wind just brought it straight up that canyon and held it tight, and it didn't escape up over the sides. It just, the wind brought the smoke right up the canyon, funneled it and tunneled it right up, and made it smoky up there. But I was never in any actual danger. But I mean, I'm not gonna stick around to find out if I'm in danger. I took off and panicked and like down the mountain. I'd never like descended a mountain so fast. It's like, am I gonna get altitude sickness? Jokingly, but yeah, that was scary. And so I didn't get very much stuff. I had spent a few minutes trying to get settled on that tailings pile, and was like, oh god, what's happening? And so I just reached around and grabbed some of these pieces, this and like 2 others that were right around me that I could see crystals on. It's like grabbing a few pieces, sticking them in my pockets in my backpack, and like open a pouch in my backpack. I'm like, throw that one in, throw that one in, run down the mountain, hey, there's one, throw that one in, run down the mountain, hey, there's another one, throw it in. I just kept running down the mountain, and actually ended up getting a couple really cool pieces, and got down safely. Would have been safe either way, but it was smoky. I wouldn't have wanted to be up there any longer in that crazy smoke anyway. Yeah, that was story time. The fun of rockhounding alone. Oh, and I was alone. I didn't have anyone with me, so I was stupid. And there's Not a lot of mountain lion reports up there. They happen, but I don't know. I had a big hammer and a big stick. But that's the little story behind this guy. Crocite is a lead chromate. Okay. That's when you do the slide and grab. Exactly, Jenny. Yep. Running and sliding and grabbing down the hill. So the host rock here, it's a very rusted out, I'm guessing one of the limestones up there, but it's just crazy rusty. It feels like limestone, looks like limestone or a sandstone. It might be a metamorphic sandstone that got pressurized and got some silica-rich fluids in there, or calcium-rich fluids. I'm thinking this is in the calcium group of minerals. I don't have very much of it, so I've been afraid to test it in acid or anything. I guess we could break off a tiny little piece and go drop it in some vinegar and see if it dissolves. And wrap it up. Do that to wrap up the stream, yeah? Test a little piece of this, maybe out of like one of these spots. Somewhere that's not pretty. Or actually, check this out. We could open this up to see more in there if I break off this chunk right here. It'll actually open up that vug a little more to see in there and give a big chunk for testing. Let's do that. I'm gonna break it open. I'm just grabbing a little pliers here. Break it open over something bigger so it doesn't get over my book or ottoman. Well, I guess it can get on the outside of my book. I don't care. All right, where was that piece? This one right here. Well, gems, that's what I'm worried about, because if the crystals are calcite, then no. Let's see. How secured is that underneath? Oh, that just came out like pulling a loose tooth. Like pulling a little loose tooth. Oh, hold on, wait. Let's get the magnifier. Been a lot more mountain lion encounters lately, and they've been getting more and more dangerous. Yeah, bear, that's, I mean... Fair point. They are dangerous, but I've also had quite a handful of encounters with Utah mountain lions. The only time they ever really came at us was when we had horses. It seemed like they were more interested in our pack horse than us. I was hoping we'd show the texture of the crystals more than my fingernails here, geez. Oh, we lost it. I had the focus. Well, let's see, look, this works well. Gotta get it at the right distance. Too much. Zoomity zoomity zoom. Okay, let's grab a little acid and dissolve this little thing. Okay, so I'm gonna start with a 6% acidic vinegar, mainly because that's the strongest acid in my house right now. So I gotta drop down my tripod. Okay, let's see what happens. Can't tell if it's got tiny bubbles coming off of it. It definitely does. But I can't tell if those little bubbles are reaction or it's soaking into the rock. There's definitely little bubbles. Well, I guess we'll leave this in here for a few hours. And come time for my next stream, we'll check on it and see how it's looking when I go live for a sale a little bit later. So I'm gonna go make some breakfast, cook some pancakes and bacon, making pancakes, making bacon pancakes. And yeah, go do that, cook my pancakes and bacon. I cook a big batch of pancakes to last me for the week. And then I will send out a notification later about going live for live sale. It does look like it's dissolving. Looks like it's mostly dissolved, actually. All the little round crystals on it kind of look like they're going away. Kind of looks like it's reducing to smaller size. Like I can now see, it's now clear and I can see the host rock under it more. I can see bubbles coming up out of it. Little tiny bubbles. Okay, there's still crystal shape there. I don't know. Very curious if this will dissolve after just a little longer. But if y'all don't mind, hit the little like. Aw, I bored someone. Just said 6 likes and went to 5 likes. I don't know if someone double tapped it. Fine, I guess I bored you to death. Sorry, bye. I'm gonna go clean this up, put my peridot away, and we're gonna make breakfast like I said. I'm always tempted to just sit and play with this stuff for hours. Turn my AC on because it's like 80 degrees in here now and I'm sweating like crazy. But I wanted it to not be loud during the stream, so I put up with the heat to just go live for a little while. But I don't want to roast my little poor dogs. I'm gonna have little hot doggers. Yeah, let's see. What do you do to keep the pancakes fresh for days? So I just put them in a big Ziploc bag and keep them in my fridge. They're gluten-free pancakes. I don't know if maybe that makes a difference, but they keep well. They stay fine. I have no problem with them. I just microwave them in the morning. Yeah, had no issues. I do the Betty Crocker gluten-free pancake mix. A lot of people don't even notice the difference. Like if I make the cookies or something with the Betty Crocker mix, it tastes just like their normal baking mixes. And like a lot of people are like, wait, this doesn't taste gluten-free. I'm like, trust me, it is. It's finally nice to see a big company like Betty Crocker do that. Yeah, and Bear, that's Rocky Mountain. That's why that was like 2 years ago, that story in Utah, 2 to 3 years ago. This last time I was out in Utah, I wouldn't go hiking without other people, so I only really made it out one day on a real hike, which is that video I just recently put out where we went to the old abandoned place on the river where the river was flowing like crazy. But yeah, I didn't want to go anywhere else because no one wanted to join me on any adventures. I was trying to find people, but didn't know you were out that way. Didn't know some other people that have channels are out in Utah or out that way. And I was like, dang, wish I was like paying attention and knew right before that I'd contacted more people. Try and get out there. But anyway, I'm delaying starting my morning. I'm gonna go do it now and see y'all in a few hours. Hey, Boot. Oh, man. Well, you missed story time, Boot. We talked a little bit about rocks, skimmed a little bit of my books. I gave maybe some useful information, hopefully. Maybe people learned a thing. I know I learned like 3 things today going through my book. I learned that Epidote is not actually part of the olivine peridot family. I thought potentially peridot was a part of the olivine family, and we confirmed that it was. And then, what was the other one? Damn, there was another one. See, I don't remember already. So I say I relearn things so many times, and my memory is so horrible. Too many safety meetings. Speaking of, time to go. Bye, y'all. See you soon.